This video is going to be covering solving systems of equations using elimination and when we need to multiply to solve. So last week, when we learned about elimination, we figured out that when equations are written in standard form, like for example, these two sets here, the way that we can manipulate them to get the variable alone is actually really simple. We can just create one big addition problem here, and we can add them. X plus 2x comes down to 3x, and then negative y and positive y cancel. 11 and 19 equal 30, and we can get x is 10. Very simple, and then we just plug 10 in for x to get y. And then we learned on Wednesday and Thursday that if we had another elimination problem, but instead of having, in this one we have, let me just change colors here, we have a negative y and a positive y, so this allows us to add very easily, but we can't add as easily with the positive 2y and positive 2y, because if we add them, we're just going to get 4y. So we learned that we can do a subtraction here, and we're going to just subtract each variable from itself. So 7x minus 8x is going to be negative 1x. 2y minus 2y is going to be 0, and then 24 minus 30 is going to be negative 6, making x positive 6. We can plug that back in and solve for y. So we learned that as long as we have in one of the variables the same coefficient, this one being 1 or negative 1, so I guess it's not the same coefficient, but the same coefficient with opposite signs we can add, and then here we have the same coefficient and we can subtract. So that solves about half of your elimination problems. However, you might run into one where the x's or the y's don't line up as easily, and so you're going to need to manipulate it further using property of equality to be able to do the same thing, which is add or subtract. This problem here is example 3 in 5-4 of your textbook. It's actually on page 279, and it does feature t and w instead of x and y because it's referring to the perimeter and the area of a rectangle, and it's trying to help you solve a word problem. We're just going to focus on the problem today. So here we have 2t plus 2w equals 26, and then below we have t minus w, and we know that that's going to be 1t. Let's change to red here. It's going to be 1t, and this is 1w. So if we were to try and add or subtract this, I'm going to go ahead and just go with addition since I see a plus and minus here. If I were to add this, I would get 2t plus 1t is going to be 3t. 2w plus negative 1w is still going to get me w, and then 26 plus 3 is 29. So that's not going to isolate a variable for us in a way that we can use it to solve. So we have to take a different approach to this problem. Again, what you're looking for when you do addition or subtraction is that you have either your x's or y's, in this case t or w, they have the same coefficient, and the coefficient, as a reminder, is the number out in front of the variable and then opposite signs. So I know that technically in the last slide the signs were different, and so that means that there's a negative coefficient and a positive coefficient, but in the sense of the absolute value of the number. So we know from last week too that when we multiply or add or subtract anything to one side, we have to do it to the other, and that's going to be property of equality. So the way that we are going to be able to solve this problem is we need to scale up this equation. So I'm just going to go ahead and write 2t plus 2w is equal to 26 here, but this t plus or t minus w equals 3 isn't going to be useful for us when we want to add or subtract. So I want to go ahead and get the w's to match so that this t minus w actually has a 2 in front of it. So what I'm going to do is use property of equality. I'm going to multiply this side of the equation by 2, and I'll multiply this side of the equation by 2. And doing that, as long as I do the same thing to both sides, it keeps it equal. So distributing this through, 2t, 2 times t is going to be 2t, and then I have 2 times negative w is going to be negative 2w, equals 3 times 2 is 6. And now, all of a sudden, I have a set of equations for a system where I can easily just add. So I'm going to go ahead and do that here. I got 2t plus 2t is 4t. And then I got 2w plus negative 2w becomes 0. 26 plus 6 is going to be 32. And then all of a sudden I can just solve for x, or for t, excuse me. So divide this side by 4, divide this side by 4. I have t is equal to 8. Now I'm going back to my original equation here. If t minus w is 3 and t is 8, 8 minus w is 3. I know that by doing it in my head that it's 5, but in case I didn't, I could say subtract 8, subtract 8. I got negative w is equal to negative 5. Divide by negative 1, divide by negative 1, w is 5. So now I have my answer as t is 8 and w is 5. So really simple here. All I had to do was multiply one of the equations by a number on both sides to scale it up so that I could use addition or subtraction to solve for the elimination to get the variables. Let's go ahead and try another example. So here I have 3x minus 5y equals negative 9, and then below that I have x plus 2y equals 8. So I can't easily add or subtract this. I'm going to have to scale up the equation, and the easiest one to scale up is going to be here. So I'm going to rewrite the top one. 3x minus 5y is equal to negative 9, and then I want to make either the y is the same or the x is the same. I could easily make the x to be 3 by just multiplying this entire side by 3. There's nothing I could multiply 2 by, that's a whole number that could easily get it to negative 5. You could always multiply by a decimal, but choose the easiest one. So 3 times, oh, I gotta multiply this side too. There we go. 3 times x is gonna be 3x. 3 times 2y is gonna be positive 5y. And then, nope, not at all. You're probably thinking, what is her math about? No. 3 times 2y is gonna be 6y, and this is positive. And then on the other side, I have 8 times 3, and that's going to be 24. So now I have my coefficients here, 3x and 3x are the same, which means if I add them together, I'm not going to get 0, I'm going to get 6x, so I need to subtract. So I'm going to subtract everything here. So I have 3x minus 3x, and that becomes 0. Negative 5y minus 6y is going to be negative 11y. And then negative 9 minus 24. So I know that 20 and 9 together is 29, 30, 31, 32, 33. So I have negative 33 over here. Divide by negative 11, divide by negative 11. I got y is equal to 3. And so now I can take this and plug it back in. Again, this one seems easier, but either equation will work. So let's go ahead and try this. I got x plus 2, but instead of y, I'm going to put in positive 3 and then equals 8. So x plus 6 is equal to 8. Subtract 6, x is 2. So now my answer is 2, 3. All right, go ahead and try the practice. I got 2 more videos for you today, and hopefully by the end of today, you'll understand how to solve these systems of equations using elimination with multiplication.